Here is something that should bother you. It bothers me. It has bothered physicists for over a century, and most of them pretend they have an answer when they do not. Why can you remember yesterday but not tomorrow? Think about that for a second. You can close your eyes right now and recall what you had for breakfast this morning. You can picture your childhood bedroom. You can hear your mother's voice from 30 years ago. The past is sitting right there in your head, accessible, real, vivid. But the future, nothing, blank, a wall of fog. You cannot remember what you will have for breakfast tomorrow. You cannot recall the face of someone you will meet next week. The future is completely, absolutely, stubbornly invisible to your memory. And everyone acts like this is obvious. Of course, you cannot remember the future. The future has not happened yet. How could you remember something that does not exist? But here's the thing. That answer is wrong. It is not just incomplete. It is fundamentally wrong. And if you understand why it is wrong, you will understand something very deep about the physics of time, about entropy, about why time only moves forward, and about the strange machinery inside your skull that we call memory. You see, the real reason you cannot remember the future has nothing to do with the future not existing yet. In fact, according to physics, the future might already exist. The past might still exist. Everything might exist all at once, laid out like a landscape, and yet your brain can only look in one direction. Why? Let me take you through this carefully, because this is where most people get lost. This is where the arrow of time becomes not just a physics concept, but a personal experience. This is where Feynman's time theory and everything we understand about memory and time collide in a way that will, I promise you, change how you see reality. First, let us deal with that naive answer. The future has not happened yet. This sounds reasonable. It sounds like common sense. But physics does not care about common sense. Physics cares about equations. And when you look at the fundamental equations of physics, something very strange emerges. They do not care about the direction of time. Take Newton's laws. An apple falls from a tree. The equations describe that perfectly. But if you run the equations backward, if you reverse the direction of time, you get an apple rising up from the ground and attaching itself to a branch. Mathematically, this is perfectly valid. The equations work just as well in reverse. Take electromagnetism. Maxwell's equations describe light, electricity, magnetism. Run them backward. They still work. Take quantum mechanics. The Schrödinger equation evolves probability amplitudes forward in time. Run it backward. Still valid. Take Einstein's relativity. Space-time does not have an arrow built into it. Past and future are just directions, like left and right. So here is the puzzle. If the fundamental laws of physics do not distinguish between past and future, why does your experience distinguish between them so absolutely? Why does time flow one way in your head when the equations say both directions are equally valid? This is not a small question. This is one of the deepest questions in all of physics. And the answer, when you finally understand it, reveals something shocking about why memory only works backward. Let me give you the first clue. It is a word you have probably heard, but maybe never truly understood. Entropy. Entropy is often described as disorder. Things tend to go from ordered to disordered. A glass falls off a table and shatters into 1,000 pieces. You never see 1,000 pieces leap off the floor and reassemble into a glass. An ice cube melts in warm water. You never see warm water spontaneously freeze into a cube while the surrounding liquid gets warmer. This is the second law of thermodynamics. Entropy increases. Disorder grows. And this, everyone will tell you, is why time has a direction. This is the arrow of time explained simply. Things fall apart. They do not fall together. But here is what most people miss. Here is what took me years to truly appreciate. The second law of thermodynamics is not really a law at all. It is a statistical statement. It is about probability, not necessity. You see, there is nothing in the laws of physics that prevents a shattered glass from reassembling. Every collision of every atom could, in principle, run backward. Every shard could bounce at exactly the right angle to rejoin its neighbors. It is not impossible. It is just extraordinarily, mind-bogglingly unlikely. So unlikely that in the entire history of the universe, it has probably never happened and never will. Entropy does not have to increase. It is just overwhelmingly probable that it will. The universe is not obeying a command. It is playing the odds. And the odds are stacked so heavily toward disorder that it looks like a law. Now, why am I telling you about broken glasses and ice cubes when we are supposed to be talking about why humans cannot remember the future? Because your memory is a physical system. Your brain is made of atoms. Neurons fire. chemicals flow, electrical signals propagate, and all of these processes are subject to the same statistical rules that govern glasses and ice cubes. Your memory is not some mystical thing floating outside of physics. Your memory is physics. And the reason you can remember the past but not the future is the exact same reason that glasses shatter but do not unshatter. It is entropy, it is probability. It is the arrow of time, not as some abstract concept, but as the concrete reality of how information flows through physical systems. And this is where Feynman comes in, because Feynman understood something about time and entropy that most people still do not grasp. He understood that the question is not really why does time flow one way. The question is why does the universe have low entropy in one direction and high entropy in the other? And the answer to that question is far stranger than you might expect. Let me tell you what Feynman understood about time that most physicists dance around. Most physicists will tell you that the arrow of time comes from entropy. Entropy increases toward the future, decreases toward the past. Fine. But Feynman asked the deeper question. He asked why? Why does entropy increase in one direction? Why was the universe more ordered in the past than it is now? This is not obvious. This is not something you can derive from first principles. This is, in fact, one of the most mysterious features of our universe, and it has everything to do with why the future feels impossible to remember. You see, the laws of physics are time-symmetric. I said this before, but I want you to really feel the strangeness of it. If you filmed every interaction of every particle in the universe and played the film backward, the physics would look just as valid. Particles would still obey Newton. Waves would still obey Maxwell. Probabilities would still obey Schrödinger. Nothing in the fundamental laws says this direction is forward and that direction is backward. So why do we experience a direction? Why does time only move forward in our perception? Here is Feynman's insight, and it is beautifully simple once you see it. The arrow of time is not built into the laws. It is built into the initial conditions. The universe started in an extraordinarily special state, a state of remarkably low entropy. And everything since then has been a process of that entropy increasing, spreading out, equilibrating. Think of it this way. Imagine you have a box divided in half. On one side, you have a trillion molecules of gas. On the other side, nothing. Vacuum. This is a very special, very ordered, very low entropy state. Now you remove the divider. What happens? The gas spreads out. It fills the whole box. Entropy increases. This happens not because there is a law commanding it, but because there are vastly more ways for the gas to be spread out than there are for it to be confined to one side. The universe is that box. The Big Bang was that initial state with all the gas on one side, and everything since then, every star forming, every planet cooling, every thought you have ever had, is the gas spreading out. Is entropy increasing? Is the universe relaxing from that special initial condition toward equilibrium? Now here is where memory comes in. Here is the physics explanation of time and memory that nobody teaches you in school. What is a memory? Physically, what is it? A memory is a correlation. It is a physical state in your brain that corresponds to, that correlates with, a physical state in the outside world. When you remember breakfast, there is a pattern of neural connections in your head that matches, in some abstract way, the pattern of events that happened this morning. But here is the key. For that correlation to exist, for your brain state to contain information about the world, entropy had to increase. Information storage requires entropy production. When light bounced off your breakfast and entered your eyes, when your neurons fired and formed new connections, when those patterns got locked into your synapses, entropy increased at every step. This is not a metaphor. This is literal physics. The science behind remembering the past, not the future, is thermodynamics. Your brain can only record events that increase the total entropy of the universe. And since entropy increases toward the future, your brain can only record events that happen in the past. Let me say that again because it is the crux of everything. Memory is a physical record. Physical records can only form in the direction of increasing entropy. Entropy increases toward the future. Therefore, memories can only point toward the past. This is why humans cannot remember the future. It is not because the future does not exist. It is not because time is flowing and the future has not arrived yet. It is because the physics of information, the physics of correlation, the physics of record keeping only works in one direction, the direction of increasing entropy, the direction we call the past. Now, you might ask a very reasonable question. Does physics allow remembering the future at all? Is there any conceivable way to have memories of tomorrow? And this is where it gets truly mind-bending. In principle, if the universe were running backward, if entropy were decreasing, then what we call the future would be what our brains could record. Memories would point the other way, but we would not experience this as remembering the future. We would experience it as remembering the past, because our definition of past is precisely the direction in which our memories point, the direction of lower entropy. You see, we do not experience time flowing. We experience memory accumulating, and we call the direction of memory accumulation the past. This is circular in a beautiful and disturbing way. The past is not defined by some external clock. The past is defined by where our records point, and our records point toward lower entropy because that is the only direction records can point. This is why the time travel paradox explained in movies never quite makes sense. When people imagine traveling to the future and then remembering it, they are imagining something physically incoherent. You cannot form memories of a state that has higher entropy than your current state because memory formation itself requires entropy increase. You would need to locally reverse the second law of thermodynamics inside your skull. And while that is not strictly impossible, it is so unlikely that you would have to wait longer than the age of the universe for it to happen by chance. So here you are, trapped in a one-way corridor. You can look behind you and see where you have been. The footprints are there in the snow, but ahead of you, the snow is fresh and unmarked. Not because the corridor does not extend forward. It might. Physics suggests it probably does. But because footprints can only form in the direction of increasing entropy, and you are walking forward into higher entropy, leaving marks behind you, unable to see marks that do not yet exist. But there is still a deeper question lurking here, a question that Feynman asked and that still does not have a complete answer. Why did the universe start with low entropy in the first place? Why was the Big Bang so special? And what does this tell us about the ultimate nature of time perception explained by physics? Now we arrive at the deepest mystery, the one that kept Feynman up at night, the one that still haunts physicists who think carefully about the arrow of time. Why did the universe start with low entropy? You see, if you accept everything I have told you, and it is all solid physics, then the arrow of time is not fundamental. It is contingent. It depends on a very specific fact about our universe, the fact that 14 billion years ago, everything was packed into an incredibly ordered, incredibly improbable state. The Big Bang was not an explosion of chaos. It was an explosion of order. And we have been riding the wave of increasing entropy ever since. But why? Why should the universe have started that way? The laws of physics do not require it. You could imagine a universe that started in equilibrium, maximum entropy, everything spread out evenly, nothing interesting happening ever. That universe would have no arrow of time, no past or future, no memory, no life, no you. We do not live in that universe. We live in a universe where something extraordinary happened at the beginning, something so improbable that it seems almost designed, and nobody knows why. Some physicists think the low entropy beginning is just a brute fact. It is just how things are. Do not ask why. Others think there might be a deeper explanation. Maybe our universe is part of a larger multiverse, and we happen to exist in a branch that started with low entropy because only such branches can produce observers. Maybe the Big Bang was not really the beginning. Maybe there is something before it that explains the special initial conditions. Feynman was always honest about what we do not know. He was suspicious of people who pretended to have answers they did not have. And on this question, the question of why the past has low entropy, we do not have an answer. We have the fact. We have the consequence, but we do not have the explanation. And yet, this mystery is precisely what makes your existence possible. The fact that you can remember yesterday and not tomorrow, the fact that time seems to flow, the fact that you experience life as a sequence of moments rather than a static block, all of this comes from that initial improbability. You are a child of low entropy. Your memories are fossils of that ancient order, degrading slowly as the universe slouches toward equilibrium. Let me bring this back to something personal, because physics is never just about equations. Physics is about understanding your place in the cosmos. You wake up every morning and the past is there, heavy with detail. You remember your first kiss. You remember your failures. You remember the taste of your grandmother's cooking. The past feels solid, reliable, real. But the future is a ghost. You can plan for it, you can worry about it, you can hope for it, but you cannot remember it because memory only works backward. And here is the strange comfort in this. The asymmetry that traps you, the one-way door of time, is the same asymmetry that makes you possible. Without the arrow of time, without the gradient from order to disorder, there would be no processes, no change, no life, no thought. The very thing that frustrates you, that makes you unable to see tomorrow, is the same thing that allows you to exist at all. This is one of those mind-bending physics concepts that changes how you see everything. You are not separate from the physics of time. You are an expression of it. Your consciousness, your sense of flowing from moment to moment, your entire experience of being alive is the arrow of time made manifest in neural tissue. When you ask why the future feels impossible to remember, you are really asking why the universe is the way it is. You are asking about initial conditions set 14 billion years before your birth. You are asking about the deepest structure of reality. And the answer, as far as we know it, is entropy. The answer is probability. The answer is that you are a pattern riding a wave of increasing disorder, able to look back at where the wave has been, but unable to see where it is going. Now, some people hear this and feel despair. They feel trapped. They feel like puppets of thermodynamics pushed along by forces they cannot control. But I see it differently. I see it as liberating. You see, understanding why time only moves forward does not change the fact that you are here now in this moment, able to experience and wonder and question. The physics does not diminish the experience, it deepens it. Knowing that your memories are thermodynamic miracles, knowing that your sense of time is rooted in the birth of the universe, knowing that every moment you experience is part of this vast cosmic process that is not depressing, that is astonishing. The real reason you cannot remember the future is the same reason you exist at all. The arrow of time is not your prison. It is your birthright. It is the fundamental asymmetry that allows complexity, life, and mind to emerge from the chaos of jiggling atoms. So the next time you feel frustrated that you cannot see what is coming, remember this. The fog ahead of you is not a limitation. It is the signature of a universe that started in a state so special, so improbable, that it gave rise to creatures who could ask the question in the first place. You are entropy becoming aware of itself. You are the universe looking back at its own history and wondering why. Feynman spent his life finding things out. He taught us that nature is strange, that reality does not owe us intuitive explanations, and that the honest answer is often, I do not know. But he also taught us that not knowing is not the end. It is the beginning. Every mystery is an invitation. Every unanswered question is a doorway. The future versus past memory asymmetry is one of those doorways. Walk through it. Keep asking why. Keep jiggling your atoms in new patterns. Because the universe gave you this one-way ticket through time, and the least you can do is pay attention to the ride.